Alright, hello everyone. Welcome back for another video. So today's topic will be introduction to function. Okay, what is actually a function? A function is just a special relation, okay, where it means that okay, every object okay will have has one and only one image. Okay, so object, one image. Okay, so that is what a function is all about. Okay, so we have two types of function, right? So you can have either okay type number one, which is a one-to-one function. Okay, a one-to-one function is where you have one object, one image, and there is no two object mapped onto the same image. Okay, and we have second type, which is a many to one function. Alright, and what is a many to one function? Is where the objects are mapped onto the same image. Okay, more than one object maps onto the same image. Okay, so let's look at some function notation. Okay, how do we express a function? Okay, so in an example, okay, we can have y equals to 50x. Okay, that's the example that's been given. Okay, so which means that y represent the number of pages, x represent the number of hours passed. So therefore we can say that y is actually a function of x. Okay, and we then can represent function in an arrow diagram. Okay, we can represent this function okay from the table form. Okay, we can draw it in arrow diagram form. Okay, and there are two type of arrow diagram. Okay, one is in okay, you have two parallel line where this is the object x, which is mapped onto the image. Okay, and the image is 50x, and the function here is function okay, you can say it's a function f. Okay, and for every x value okay that you have, so x is 1, x is 2, x is 3, x is 4, and x is 5. No. Okay, we have until 6. Okay, and is mapped into the image 50, 100, 150, 200, 250, and 300. Okay, so it's mapped onto okay all the object from the x is mapped onto the image. Okay, and please make sure that you have arrow to show that. Okay, so you have all the arrows mapping all the object to its image. Okay, and please make sure you label this is the object side, which is x, and then this is the image side on the right is 50x, and you have a function okay that maps all the object to the image okay with an arrow, and please name the function. Alright, so another type of an arrow diagram is in circle form, where you have one circle for object and one circle for image. So you just list out all the object, then map onto all the images. Okay, so that is just an example there. Okay, just a sketch out. Okay, so it's just the same concept where this is in two parallel line, or you can represent them in two ellipse, okay, or two oval shapes. Okay, so next, if you move on to your notes, the second page, alright, so we can write this function, okay, y equals to 50x as, okay, you can express it as fx is represented by 50x. Okay, so this, okay, you read this as f maps x onto 50x, right? So all this object, okay, another word for that will be, okay, we call this the object and we call this the image. Okay, another name for that will be we will say that these are a set of object. Okay, another name of sets of object will be domain. Okay, then sets of image will be called, okay, or referred as range. Okay, so all these number, okay, if you want to write the sets of object, okay, we write it in a curly bracket. So you have 1 2 3 4 5 and 6. Okay, and all the sets of image or the range will be written in curly bracket. So you have 50, 100, 150, 200, 250, and 300. Okay, so make sure you write them in curly bracket there. All right, so another way of writing this, okay, f maps x onto 50x. Okay, another way of writing that will be, you can write this in, okay, f bracket x equals to 50x. Okay, so they mean the same thing. Okay, we should read this as f of x is equals to 50x. All right, this one you read it as f maps x onto 50x. Okay, so both of them means the same thing actually. All right, so let's move on to example number 2. Okay, in example number 2, you have, okay, a set of object there. Okay, sets of object P where you have A, B, C, D, and you have sets of image, okay, where image Q where you have W, X, and Y. Okay, and then D is mapped onto Y, then you have A is mapped onto X, and C is mapped onto W. Alright, so is this a function? Okay, you need to determine whether is that a function. Alright, and in this case this is not a function. Alright, why is it not a function? Is because this object, alright, object B, alright, object B, okay, so because object B actually don't have any image. Alright, therefore it is not a function. Okay, so if we look at the second diagram, okay, in the second diagram where we have a set of object, okay, where we have 3 person, Jay, Asri, and Bala. Okay, and we have a set of images where we have 160, 163, 167, and 170. Okay, then J is mapped onto 160, Ashri is mapped onto 163, Bala is mapped onto 167. Okay, and this is the height of. Alright, so is this a function or not? And we will say that this will be a function. Okay, it is a function because all the object here is mapped onto one image. Okay, and then, okay, even though there is one extra image there, okay, it's okay there. Okay, but because our main aim is that every object has an image. Okay, so this is an example of a one-to-one function. Okay, because all the object only has one images. All right, then if you look at diagram C, okay, diagram C where you have triangle, trapezium, and square, okay, which is mapped onto 180 degree and 360 degree. Okay, so a triangle is mapped onto the 300 mapped onto the 180, then the trapezium and the square are mapped onto the 360 degree. Okay, with the function sum of internal angle. Alright, so is this a function? Yes, this is a function. Okay, because all the object has an image. Okay, and this is an example of a many to one function. Okay, because they are, okay, we have two objects mapped onto the same image. Okay, so it's a many to one function. Okay, then the fourth example there. Okay, if you have 16 and 49 with the image of -7, -4, 4. Okay, so the function is square root of. Okay, so square root of 16 is 4 and -4. Then square root of -7 will be square root of, okay, so square root of 49. Okay, so 49 square root of -7. Alright, so is this a function? So we will say that this will not be a function. Okay, not a function. Why? Is because this object 16, okay, has two image. Alright, so this is not a function because you have one to many. Okay, and one to many is not one of the function. Okay, because we only have one to one function or many to one. Okay, we don't have one to many. Alright, so that will be for example number 2. Okay, moving on to example number 3 now. So we have two functions h and k, given that h maps x onto 2x plus 3, and we have k maps x onto x squared minus 1. Okay, where you have a domain of h and k, right? Your domain is given, okay, -1, 1, 2, and 3. Okay, so first question, find the range of h. Okay, so if you remember just now, earlier on, we can write this in another way, which is h of x is equals to 2x plus 3. Then k of x is actually x squared minus 1. Alright, so they are the same. Okay, we can write them in another form only. Okay, so these two, okay, so I'm just rewriting h maps x onto 2x plus 3 become h of x is equals to 2x plus 3. Okay, so our first task here is to find the range of h. In order to find the range of h, what you need to do will be substitute the domain into our function h. So you know h of x is actually 2x plus 3. So domain is actually the x value. So when x is equals to -1, okay, so x become -1. So you have 2 bracket -1 plus 3. Okay, so 2 times -1 is -2. -2 plus 3 will gives you 1. Okay, so do the same thing for h of 1. So when x is equals to 1, so we're finding h of 1, so you have 2 bracket 1 plus 3, which is 5. Then h of 2 will be 2 times 2 plus 3, which is 4 plus 3, that gives you 7. Then h of 3 will be 2 times 3 plus 3 gives you 2 times 3, 6, 6 plus 3, 9. Okay, so your answer range will be equals to, right, okay, always write them in curly bracket. So we have 1, 5, 7, 9. So that will be your answer for part A part 1. Okay, A part 2, find the range of k. So we are doing the same thing for function k. we know that k of x is x squared minus 1. Okay, using the same domain, because the question say the domain of h and k are the same, right? Negative 1, 1, 2, and 3. So find k of negative 1, which means that x equals to negative 1. So you have negative 1 square minus 1. Negative 1 square means negative 1 times negative 1, so it's a positive 1, minus 1, so it's a 0. K of 1 will be 1 square minus 1. Okay, 1 square is 1, minus 1, 0. K of 2 will be 2 square minus 1. So 2 square is 4, 4 minus 1, 3. Then the last one, k of 3 will be 3 square minus 1. 3 square is 9, 9 minus 1 is 8. So therefore, your range, okay, range of k, okay, function k can be written as, okay, because we have repeated range value, so we only write it once, so it goes 0, 3, and 8. Okay, so that will be your range of k. Alright, so then moving on to part B. Okay, part B, you just need to draw the arrow diagram. Okay, so for function h, okay, B part 1, we are drawing for function h. So we are drawing using the two parallel line. The left hand side is the domain x, right hand side is your range, which is the function 2x plus 3. Okay, so x is mapped onto 2x plus 3, okay, with the function h. So let's list out the domain in function h. Okay, so we got the negative 1, 1, 2, and 3. Okay, so if notice, it's in order. Okay, so please don't, okay, so the domain is in order and your range also must be written in order. Okay, so we got 9, 7, 5, 1. Okay, so from there, map it. So all the object map to its respective image. Okay, and make sure that you have arrow drawn. Alright, same thing goes to the next function for B part 2. Okay, so for B part 2 also the same thing. We need to draw the arrow diagram for function k. So domain x is mapped with function k, and then you have function is x squared minus 1. Domain is 3, 2, 1, and negative 1. Your range will be 8, 3, 0. Okay, so map the object with its respective range value. Okay, please map it correctly. Yeah, okay, so this one should be there. Okay, then negative 1 and 1 is mapped onto 0. Okay, so that will be your arrow diagram. Then now we're moving on to part C. Okay, identify what type of function are those. Okay, so the first one, function h, what type of function will this be? Okay, if you look at it, it's a one-to-one function. Okay, what about function k? Okay, if you look, okay, it looks like it's a one-to-one, but then when you look at object 1 and negative 1, we have two objects mapped to the same function. So it's no longer a one-to-one, but it will be a many-to-one function. Okay, right? So that is the end of example 3. So let's move on to example number 4. Okay, example number 4, where you have fx is equals to square root 2x plus 3. Okay, part A, find f of 3. Okay, so which means that x is become 3. So you just need to change to x become 2 times 3 plus 3. Right, 2 times 3 is 6. 6 plus 3 will be 9. square root of 9 will be 3. Okay, so same thing goes to part B. F of negative 1 over 4. Okay, so which means that you are changing x become negative 1 over 4. So you have square root 2 multiplied by negative 1 over 4 plus 3. Okay, so from there, okay, simplify the one inside the square root. So you have 2 times negative 1 over 4 is negative half plus 3. Okay, that gives you, okay, let's go up. So that is actually equal to square root, okay, minus half plus 3 is actually 5 over 2. Okay, so that is example number 4. Okay, so please use your calculator and evaluate this value. Okay, then round it up to 368. Okay, so always don't try not to leave your answer in square root form. Okay, then last example, example number 5. Okay, in example number 5, you have f of x is equals to ax plus b. Okay, then you are given two conditions. F of 0 is 2 and f of 1 is actually equals to 5. Alright, so you have to use these two conditions to find the value of a and b. Okay, so for part A. So let's start with f of 0. Okay, is equals to 2. Okay, f of 0 equals to 2. Okay, that means that your x become 0. So ax plus b become a times 0 plus b. Okay, that is equals to 2. A times 0 is 0. 0 plus b left with b. So b is equals to 2. Okay, one answer. So which means that we need to use the second condition, f of 1 is equals to 5. Okay, f of 1 means your x is 1. So you have a times 1 plus b equals to 5. A times 1 is a, plus we know that b is actually 2. Okay, so substitute that in, equals to 5. So move plus 2 to the other side. So therefore a is actually equals to 5 minus 2. So a value of a is actually equals to 3. So your function f of x will be ax plus b, right? So it become a is 3, so it's 3x plus 2. Okay, then b part 1, where you are asked to evaluate, find f of 3. Okay, that means that your x change become 3, so you have 3 times 3 plus 2. Okay, 3 times 3 is 9, 9 plus 2 is 11. Okay, so f of 3 is actually equals to 11. B part 2, finding f of negative 4. Okay, so same thing, x become negative 4, so 3 bracket, x change to negative 4 plus 2. 3 times negative 4 is negative 12. Negative 12 plus 2 gives you negative 10. So f of negative 4 is actually negative 10. Okay, last one, part C. Okay, hence evaluate. Okay, evaluate f3 minus f of negative 4. Okay, so from part B, we found out that f of 3 is actually, how much is that just now? F of 3, okay, is 11. Minus f of negative 4 will be negative 10. Okay, so we get the value from the previous example. Okay, from part B. F of 3 is 11. F of negative 4 is negative 10. Okay, so we just need to substitute that in, then simplify. So we got 11 minus times minus gives you plus. So 11 plus 10, answer should be 21. Alright, so that's the end of the notes. Alright, so hopefully you can understand function by that. Okay, so hope to see you in the next video. Bye bye.